Hello, on this video I'm going to show you my table design for my OneFinity CNC. I previously did build the table, the base of the CNC using Misumi 250mm by 1200mm, and let me actually open that CNC. Let's see. Let me start first with that. So here you can see. Give me a sec. Let's do a perspective mode, and then there you go. So I used a 250 by 1200, and then 20 by 60mm extrusion profile. The length is 1250. The reason I picked the 1250 is there are two reasons. If I decided to make this all aluminum, I can buy additional 3 of this and put it in the middle and replace the MDF. That will be exactly 1250, so 250 times 5. Second is, based on my calculation, because this extrusion profile, they won't align perfectly on the mounting hole for OneFinity CNC. If you notice, I only have 2 for foot of the 1F. So here it's aligning here, it's aligning here too. But I can in here. My original plan is to actually just drill here a hole in here and then do tap it, do a tapping. So I can just use a screw, because these are aluminum, I don't need to, or you can actually have a bolt underneath, but I think having tapping this is easier because it's aluminum. But when I built this, when I got my OneFinity and tried just using 2 screws, they're already locked in. It doesn't move at all. They're way flat. So decided, you know what, I'm just gonna use 8 bolt, and they're more than enough to secure the OneFinity. And then I have 2 MDF. Notice there's a cat in one. You notice in the beginning I scroll, because the reason I can take out all the 6 screws, take it off, and then there you go. I have a vertical way to do cutting of wood. This is very useful for doing dovetail joints. Like if you see some YouTube video, they do some intricate dovetail joints that are very hard to do it on hand. So you can do it. You can. I will probably play later with this. So this is my table. Right now I already have this set up, but right now it's just on. I just put this on top of my IKEA flimsy table, which it's wobble crazy. But so far, even if it's wobble, it's fine, and I can still cut. Doesn't affect the quality. It's but it looks like it's gonna fail on the very sudden change of this. I guess the spindle. Like if I put the 10,000 jerk on the max jerks on the 1F, it's wobble crazy. So that's the reason I start. Now I'm gonna start building my permanent table. So here's the design, the final design I come up. Let me switch on perspective mode again. So here, the table, the main framing I use is 40 by 40 or 40 series aluminum extrusions. And based on my calculation, the maximum deflection is still under the maximum. So it's still under the limit. I just assume that the 1F plus the extra MDF plus the super tank bed I have, the 250, the total gross weight of this weight is 300 pounds. And based on the calculation with this span of aluminum, because the plan is If you notice this is actually rotating. And the main mechanism that provides rotational is it's just like an M5 screw in here. 2 M5 screw, one on each side. So I was hesitant to actually do this initially because I was thinking that M5 screw won't hold it, or the aluminum extrusion is not rigid enough. But in fact, when I did my research, the length of this, which is a 600, I think this is like 630. When I do a calculation with 2 supporting and the deflection of this is 0.6 millimeter on a 300 pounds weight. But that's just for one extrusion. We have 2 on both sides, so we can divide that. So my deflection is probably 0.3, and the maximum based on the calculation is 1 to 1,000 of the length, which is, if this is 630, the 1 to 1,000 of the length is 0.63, and if my deflection is 0.3, I'm way below the limit. And if you notice, that calculation is based on 2 supporting end. I have a supporting in the middle, so technically this also add more support. So the weakest point now, I think, from why I'm hesitant to build, is the M5 screw I'm gonna use. I was thinking to use M8, but unfortunately, if I want to use an M8, I also need to change this aluminum extrusion, because I cannot put this. I can only bore. I can only tap this up to 5 millimeter. So M5 is the only option I have. But again, I did a research for shear capacity of an M5. I used a 12.9 class bolt. It's still more than enough to hold 300 pounds weight, and that 300 pounds weight is only temporary. This bolt will only hold that weight. Those 2 bolts, not just one, those 2 bolts will hold this weight temporarily during the rotational, because once it's, for example, this is, I call this CNC mode. Once in CNC mode, I can add additional maximum of 3 screw or 6 screw per side. One planning is only one, and so there will be 1, 2, 3, and other side is another 3. There's 6 bolts that will spread out all the weight capacity distribution of this. Let's say assume against 300 pounds. So it's not just the center one. And then on the storage mode, so this is 90 degrees. There should be, okay, I forgot to add a hole in here, but there will be a hole in here too. So you take out the 2 holes in here, and then you just move the bolts in here, 1 in here, and then 1 in here. So in storage mode, there will be 4 bolts. Now on the workbench mode, it's the same one as in CNC mode, which is you just put back all the 6 screw, actually the 4 screw, because the center one is always permanently connected. So I think that's still more than enough. Now the hardware that they use for joint is, they call it blind joints. You can also buy this on Misumi. By the way, all this aluminum, I will buy that. It's available to Misumi. I initially quoted on 8020.net, but the lead time is very, like, 7 days for not even custom cut. I mean, it's just like 7 days for order with specific cutting. And Misumi, plus their delivery charge is almost $100 with all these sets. And then I tried it on Misumi. I was able to find all the equivalent hardware and aluminum extrusion. Although they're compared to 8020 and Misumi 40x40 series, Misumi is a little bit thinner in comparison. But I don't think that matters, because it's still under the specs of the weight I'm planning to hold, to put the load on this aluminum extrusions. and they're a lot cheaper. So I'll show you how much it will cost. So this is the bill of materials. 229 without shipping yet. On 8020.net it's $400 including shipping. And advantage on Misumi, if I want, I can pick this up too if I wanted, because it's just like an probably just 35 miles drive from my place. Their warehouse is close to where I live. But I look on the shipping, because maybe I'm closer. Their shipping is just less than $30, so I might just ship it. I don't need to drive all the way there, unless and the lead time. And look at their lead time, just 1 day. If I order this, I can probably get this weekend. On 8020.net, it's 7 days minimum. So that's the reason I switched to Misumi in terms of hardware and aluminum extrusions. I still need additional T-nuts for attaching the MDF. Both bench dog ass, and then also the baseboard. But you can buy those on Amazon. It's much cheaper. I think you can buy like 50 pieces under $10. Just those regular T-nuts. I think there's a T-nuts in here. It's a different size for this one, and different sizes for this one. I already measured this. I think I already ordered on Amazon a T-nut that I can use it here. In fact, they're a lot cheaper if I buy this on 8020.net or Misumi. So I only buy things that I cannot buy on Amazon on Misumi. There you go. That's hopefully you find some interest on this table design. So I cannot share this design until I've proven it's working. But for now, this is more basically just experimenting. Like I said, like they're concerned that will this is rigid enough that it won't wobble, because if you look there, I don't have if you do a solid wood, you can have a solid sheets in here in these directions. Or if you don't want to pull rotational, you can also add another sheets in here, which drastically give you additional support for both direction to avoid wobbling, because you're basically just good luck compressing those sheets in that direction. This one, I was just hoping that this type of blind joints, although they said this is the strongest joints for the aluminum, and you notice that I'm using double on each corner. So I'm also hoping this provide enough compression to keep enough rigidity on this table. Worst case is if it doesn't work, I'm just gonna create an L-bar aluminum here. I'll just CNC myself. Just gonna buy a sheets of aluminum. That's why we have a CNC, so we can or buy. I think I might just create one, because some of them are specific to my dimensions. Also here, if you notice here, this also require machining. Then again, I think I'm planning to use our OneFinity to actually make this counter bore for the blind joints. So I'm gonna probably just create a jig on the table or buy a fixture, so I can like run multiple but run quickly. Either I can do a drill press, but I think since we have a CNC, well, we should use the CNC to actually counter board is. This is very easy for the CNC machine. All we need to do is make sure we have a fixture that we can do a repeatable boring of this aluminum extrusions. Okay.